Hey everyone, and welcome. Today, we're jumping right into one of the biggest questions you can ask. What is our universe actually made of? We're talking about the chemical elements.
And I mean, seriously, just take a second and look around. The phone or computer you're watching this on, the tree outside your window, the air you're breathing, even you. What is all of this stuff really made of? Well, the answer is both way simpler and way more amazing than you might think. So to answer that big question, we first need to get familiar with the universe's basic ingredients. These are the fundamental bits and pieces that build everything we can see and touch.
At the heart of it all is the chemical element. And what is that? Well, it's the purest stuff you can get. It's a substance made of only one single type of atom, and you absolutely cannot break it down into anything simpler using chemistry. It's kind of like a primary color. You just can't make red by mixing other colors. It just is.
You know, the absolute best way to think about elements is to picture the universe's ultimate Lego set. With just about 118 different kinds of bricks, you can build literally everything. Everything.
Now, let's nail down a really important difference here. Element versus compound. So, the oxygen gas we breathe, that's an element. Yeah, its molecules have two atoms stuck together, but they're only oxygen atoms. Water, on the other hand, is a compound. Its molecules are made from two different kinds of atoms, hydrogen and oxygen, bonded together. It's the difference between building with only red Legos versus building with red and blue Legos.
Okay, so we know an element is made of one kind of atom. But what exactly is an atom? To figure that out, we've got to take a little trip right into the heart of an element. An atom is basically the smallest possible piece of an element you can have that still acts like that element. Imagine you had a bar of pure gold, and you kept cutting it in half again and again and again. The very last thing you'd be left with that is still gold would be one single atom of gold.
And if you could zoom in on any atom, you'd find a similar setup. Right in the middle, there's this dense little core called the nucleus. And inside that, you have positively charged protons and neutrons, which have no charge at all. Then, whizzing all around that nucleus, you've got these tiny, negatively charged electrons. Every single atom is made of these same three parts. Now, this brings us to a really fascinating puzzle. If all atoms are made from the exact same three particles, what actually makes them different from each other? What gives an element its unique fingerprint?
I mean, what makes a carbon atom totally different from an oxygen atom? Or an atom of gold different from an atom of iron? They all have protons, neutrons, and electrons. So, what's the secret sauce?
The answer is actually incredibly simple. It's the number of protons. That's it. Any atom in the entire universe that has exactly 6 protons is a carbon atom, period. If it has 7, it's nitrogen. If it has 8, it's oxygen. This magic number is called the atomic number. Just think of the atomic number as an element's permanent, unchangeable ID card. It's the one thing that defines it. Hydrogen is number 1, helium is 2, all the way up the list. No two elements can ever have the same atomic number.
But wait, you're probably thinking, what about the other particles? Well, this is where it gets cool. If you change the number of neutrons, you create what's called an isotope. So for example, most carbon atoms have 6 protons and 6 neutrons. We call that carbon-12. But a few have 6 protons and 8 neutrons, and that's carbon-14. Now notice, the proton count is still 6, it's still carbon. It's just a slightly heavier radioactive version that scientists can use for cool stuff like figuring out how old ancient fossils are.
This actually brings up a really interesting little brain teaser in chemistry. If a chunk of an element can have different isotopes mixed in, is it still technically a pure substance, or is it kind of a mixture?
And the answer is, well, it can be both. Some elements, like gold for example, pretty much only exist in nature as one stable version. So a gold bar is pure through and through. But most other elements, like hydrogen or the carbon we just talked about, exist as a natural mix of their different isotopes. It's still chemically pure, every atom is a hydrogen atom, but it's technically a mixture of different weights. Okay, so with 118 known elements, each with its own personality and properties, how in the world do we keep track of them all? Well, luckily for us, scientists came up with the ultimate cheat sheet for the universe. It's the periodic table. And you really shouldn't think of it as just some complicated chart you had to memorize in school. It's way cooler than that. It's like the universe's recipe book. It lists every single ingredient we know of, all laid out in perfect order based on that all-important atomic number. See? Each element gets its own little box. It's got its name, a short symbol, and its defining feature, that atomic number, the proton count.
So hydrogen, H, is 1. Carbon, C, is 6. And gold, Au, is way down at 79. It's just a perfectly logical system.
So we know what elements are, and we know how we organize them. But that leaves one final epic question. Where did all this stuff come from in the first place? The answer isn't here on Earth. It was written in the stars. Okay, the story begins about 13.8 billion years ago with the Big Bang. That event created pretty much all of the hydrogen and helium, the lightest elements. Then, for billions of years, stars have been acting like giant cosmic furnaces, fusing those light elements together to make heavier ones, like the carbon and oxygen inside your body. But to get the really heavy stuff, like gold or silver or uranium, for that you need the unbelievable violence of a supernova, a giant exploding star.
And this all leads to one of the most beautiful and mind-blowing ideas in all of science, something the great astronomer Carl Sagan said perfectly. The iron that's in your blood, the calcium in your bones, the carbon that makes up your DNA, every single one of those heavy atoms was forged in the heart of a star that lived and died long before our own solar system even existed. We are, literally, made of star stuff.
Wow, okay, we have journeyed from the tiniest particles all the way to exploding stars, so let's bring it all home and boil it down to the 5 key things you should remember.
All right, number 1, an element is a pure substance, made of just one kind of atom. Number 2, an atom's true identity is decided only by how many protons it has. Number 3, isotopes are just different flavors of an element with more or fewer neutrons. 4, the periodic table is our amazing cheat sheet that organizes all the elements by that proton count. And finally, number 5, remember that all the building blocks of our world and of us were forged inside stars.
So the next time you look in the mirror, just remember what you're seeing. You're a collection of ancient atoms, born in the Big Bang and cooked in the hearts of stars. You are the universe, having become aware of itself. So the only question left is, what are you going to build with your star stuff?